Okay, so next problem is a sum diagonal element. Create a function diagonal sum that will sum the diagonal or anti-diagonal elements of the square 2D square matrix. Okay, so mat2, so diagonal sum accept the two input argument. One is a matrix, 2D matrix, direction. If direction is the diagonal, so summing the diagonal element. If the direction is the a diagonal, this anti-diagonal element in a input matrix. Okay. Actually, we solved a similar problem before. Okay, so if you see the operation part, yeah, this one. Okay. Okay. So these are script to convert the matrix A to matrix BC. Okay. So these are the assigned new value to the diagonal element, right? But C is assigned to the anti-diagonal element. Okay. This one is assigning the new value. But this problem, so we are reading the value from the diagonal element. Okay. Those are two problems are similar. So let me first copy this code. The store Homer model 7 sum diagonal elements, okay, and function sum diagonal sum mat the direction. Okay, so here, depending on the direction value, we need to decide if we are reading the diagonal element or the anti-diagonal element. So we are designing the if statement. Let's say string compare direction is the diagonal, else if string compare direction a diagonal element. Okay, else, and then error, wrong the second input argument. Okay, so this we already learned about this syntax, right? So oh yeah, this one, right? Depending on the lowercase, no, this one is a letter case. So letter case input, if it is a uppercase, so we are counting the number of uppercase letter. If it's a lowercase, we're counting the lowercase letter. And then otherwise, we can producing the error message, right? Okay. Or we can use the, oh, let me do this. We can also use the switch statement. Switch, what is the variable that we are going to vary? The direction, right? Case that is a diagonal, case a diagonal, otherwise it's the same error message like this. Okay, does it make sense? Okay. Okay, then let me pull up this slide. Okay, there are several ways to do that. One way is we can use the diagonal built-in function, right? This one's give you all the diagonal elements. So diagonal elements. Okay. Then some diagonal become a sum diagonal element. Okay. Or so we can write this as a 1 line like this. Okay? Make sense? Okay. How to access the anti-diagonal element? That is so think about we are extracting this anti-diagonal element. One way is we are flipping this matrix from the left and right so that this anti-diagonal element is placed on the main diagonal. So that's why we are using flip LR. Okay? Yeah, that's it. Run it. Writer. Do you understand this logic? Okay. Let's use the logical indexing. Okay. The structures are same, and then the size is mat 2D. Size mat 2D 1. So 1 and second dimension are same because that's 1 is the square matrix, right? The index is the logical I n by n, right? Or you can simply I n. Okay? Those are the same. And then we are reading the diagonal element using this logical indexing matrix, right? So mat 2D T index, that is the diagonal elements, right? And the sum diagonal become a sum diagonal element. Okay. Does it make sense? Okay. Let's debugging this one. Stopping here. Okay. Mat 2D is a 5 by 5. Mat 2D is a 5 by 5. Mat 2D is a 5 by 5. Run it, and it's the 5, right? And then the index is the 5 by 5 identity matrix, right? So logical identity matrix. We are going to use this logical array as a logical indexing matrix. So then run it. Mat 2D diagonal elements, comma 21, 48, 17, 21, 49. Okay. So some diagonal become a, oh sorry, oh this error comes from the here because we run the diagonal sum again using the A diagonal, right? Okay. And copy this code, select smart index, indent. Okay. How to change this code? This one, you can just simply flip LR, right? Like this one. Flip LR or the flip horizontally. Okay? Make sense? Okay, let's move on. Alright, and some diagonal become on. Yeah, everything is the same except for this one. So run it. No error. Okay. So I think the iterates are fine. The reason I am telling this strategy is you need to know how to use this logical indexing for your application. Okay? Make sense? Okay, good. Can copy this code. So let me delete this part. So move to in the bottom. Copy and paste here. Okay. Run script. No error. Submit. Okay. Good. Okay. Next question is the building sensor installation function. Okay. I'm not going to solve this problem because you're still working on the building sensor installation. But the underlying the logic is exactly same. Okay. This one is find out the final location and the max average force. The problem that you're solving right now is that you're only finding out the final location, right? But you have to, find out that this is maximum average force to find out the final location. So please, please making this highest force function based on your script that you submitted for homework 5. Okay. 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 Next question is the most non-zero elements row. Again, the quiz 3 is there are 2 or 3 problems. It's a very similar format with this question. Okay, it's a very short, but you need to develop your own logic to solve this problem. Okay, most non-zero elements row. Okay, so let me first copy this code. Okay, so you need to create a function most non-zero row that has a 1 input and 1 output. The function is the find out ID row, so row index from the mat2d. Okay, output ID row, the row index is the row with the most non-zero value. For instance, the mat2d is like this. Second row is only the 1 0, right? So there are 3 non-zero elements. That's why ID row become a 2. But if there are multiple rows having the same most non-zero element, you always return the first one. So in this case, first and the second row have 3 non-zero element. In that case, you need to return 1, not 2. Okay? Make sense? Okay, good. Okay, the function header is the function id row most non-zero row mat2d. Okay. How to find out the non-zero row? That is, we are going to use the operator. Okay. Okay. Let me first solve this problem using the loop structure. Okay. That loop structure is much more familiar with with you to develop this programming logic, right? So how to design this loop statement? Let me first find out the size of the mat2d. Okay, and row and column and size the mat2d. Okay. So we are making the loop structure is equal to 1, 2 row, right? So that we are accessing each of the row. Okay. So we make the variable name is non-zero. Okay. That is the size is the 1, 2. Let's do this. Okay. Because we are counting the non-zero elements of each of the row. That's why the non-zero become initialize with nr by 1 or the 1 by nr. Okay. So how to count the non-zero element? Maybe you could design another loop structure like this. I'm not saying that this is the good answer, but I'm just mimicking your thought process. Okay. If I were the students, you kind of the thinking that this kind of the logic. Okay. Okay. So f mat to be ii and zz zz equal to is not equal to 0. Here non-zero ii non-zero ii. Okay. Do you remember that we developed this types of the problem? That is this one. Yeah. Do you remember that? This one is summing up the row, right? It's in the horizontal direction. So we make a two loop structure, and then we are adding this summing up the value in the at the same row, right? And then those values assigned to the vector 1, right? This is exactly same logic, right? Only difference is that this one is that we are adding the value, adding the element value to this vector 1. But this one is we just counting. Okay? It's counting the value. So num and non-zero is the initialize set to the 0, right? This script is to keep adding the 1 if there is a non-zero element here. Does it make sense? Okay, maybe, what about this one? Task to row, and task to row is the ii's, like this, okay? And then task to row, so jj's element is not equal to 0, you're adding the 1. Do you get this point? Let's debug this code. Okay, mat2d is still too large. Let's limit the size. So n is equal to 5. Then run it. Mat2d is a 5 by 5. Okay. Task row is the. Okay, so make it larger. Clear to the. Okay. Task row is the first row, right? JJ is a 1, 2, and C, right? So number of the column, right? And then if the task row, so first element is not 0, right? So condition statement is true. So this action statement is executed. So 1 is added to the non-zero variable, right? At the ith location. ii is the row location, right? Now is a 1 added. Second element is a non-zero, right? That's why added the 1 again. Okay, so if you stop here, once you finish this, okay, here, let's finish the inner loop, and then I is still 1, but we are adding all the non-zero element, and the first row that could be 5, right? 4. Okay, 1, 2, 3, 4, right? That's why first element is a 4. Okay? Does it make sense? Okay. And then what do we do? Find out its location. That is the mean, right? No, max, right? Non-zero, non-zero. we don't need the first argument. First argument is the maximum number, right? We need this ID, right? Simply like this. If there are more than the one maximum value, they return the first location, right? That's why you can satisfy this condition, right? Yeah, that's it. So let's test it. Here, what is the ID row? There's a second. What is the mat2d? See this? Non-zero elements are 5. Second and the fourth, there are 5. But here, we return the 2 because this one is the first one, right? Okay, does it make sense? Okay. This is the way of solving this problem using the loop statement. But I highly recommend that please use the vectorization. Okay? How? That's simple. mat2d what value assigned to this logical mat2d? Okay. 1 is the non-zero element. 0 is the zero element. This is zero location, right? So see this? If this condition is true, this means the value is not the 0, right? Makes sense? Okay. Let me run mat2d. mat2d is this one. So if you do this operation, operation, see this? 0 is a 0. Non-zero location is the 1. Okay. How to summing up this non-zero? How to find out the number of non-zero value? We can summing up in the horizontal direction, right? So we can simply horizontal direction. Okay? That's this one. Okay, then we are using this code like this. Okay? mat2d ID row is the second one. That's interesting, right? Okay. So see this, if you apply this operator, what operator do we use? This one. And then vectorize your code. You can solve this problem without introducing this double loop structure. It's a nested loop structure and an if statement, right? We can do all this process using this two line. Even in this two line, we can shorten like some like this one. Okay? We can do it the one line like this. Do you agree with this power of the operator? Okay? I guess the operator is the beauty of the MATLAB programming. Okay, so copy this code or copy this function here, and then paste here. And then run script first, and then submit it. Okay, good. All right, and then final question is the replication of the built-in function. So mean and sum. Okay. I think here's the A and B is exactly same structure. So we are just replicating the sum or the mean function. Okay. Do you recall that those are the sum, mean, and median is it's exactly same syntax of the input argument, right? And their operation. Okay. So here my sum is the accept the two input matrix 2D and then dimension. If the C specify each column will be summed. Okay, is a vertical direction, right? R is each row will be summed. That is a horizontal direction. A is specify all elements is a sum. All elements will be summed. That is all element, right? Okay, we are designing this same function of the sum using our own code. Okay, that function name is my sum here. Okay, but here you cannot use the malloc built-in sum function. Okay. Okay, so let's store mode 7 built-in function in sum. Okay. Copy this code. Okay, my sum function sum value my sum matrix 2D dimension. Okay, so here dimension is a character vector, right? So you can use a switch statement to do the operation depending on this dimension, or you can use the if and else statement. If dimension go to C, else if dimension equal to R, else if dimension equal to A, else header wrong dimension argument, right? But you don't have to this error function in your function to solve this problem. I'm just letting you know that this one is kind of the common practice to let the user know that. So the user used the incorrect this input variable. Okay. By the way, one thing is let's move this one. Yeah. Let's compare these two code. Okay. But when I use the here, yeah, this part. I use the string compare, right? But here I use the this so relational operator, right? So why I did not use this relational operator here? That is, let's say, diagonal equal to diagonal is not the single logical vector. Okay, that is not the true and false. That is the logical array. Why? Diagonal is the 1/4 logical character vector, right? So you're going to compare the two character vector 1/4, 1/4, two character vector. That's why the output is the 1/4 logical vector. That's why I did not use this one, this logical this syntax. If you're really wanting to use this syntax, you need to use the all. Then this causes a check that these two arguments are same. My point is that rather than string compare, you can write a script like this, a string. What is the string compare? Oh, sorry. This one, or you can use the all like this. Can you get this point? Okay. So we could use the is equal built-in function to make the separate operation depending on the dimension input. How to summing up the value in the vertical direction? I already showed this slide, right? This one. This one is the summing up all the element in the horizontal direction. That's why it said this one is 2, right? So horizontal direction. So you can use this code. You can use this code to here, or we cannot use this sum function, right? So that's why this is the only way to do that. Okay, so okay. Let me close this one. Okay, so let me first define find out their size and see. Okay, matrix 2D size, and then your output some value is you're adding the value in the vertical direction. This should be 1 by and C, right? So for II is equal to and C, right? And for JJ is equal to 1, 2, and R. Okay, and then here some value II is the some value II plus a matrix 2D JJ. Okay, so the same logic, the difference is the output is D and R by 1, right? Because if you add all element in the horizontal direction, output value become a column vector, right? This should be R, this should be C, right? So R and yep. So here, okay. Sorry, this should be JJ II, right? In this case, II is JJ. Okay. So here, so the II is equal to 1, that is the first column. You're adding the values in the row direction, it's a vertical direction, right? To the some value at the ith location, okay, ith column. But here, this II is equal to 1, 2, and R. JJ is equal to 1, 2, and C. So these are adding the value in the horizontal direction, right? So that's why II is a row, JJ is a column. So you keep adding all the element in each row, right? Okay. Does it make sense? Okay. What about this one? This one is the can just okay, can just okay, some value become 0, right? Can some value keep adding the value the all element, right? Okay, does it make sense? Okay, let me first test this one first. Okay, run it. Okay. Okay, so A. Okay, my sum. Oh, it's a case sensitive here. Run it, no error, right? But why this one is a pre now? Oh, here. Okay. Clear. Run it. Okay. No error. Okay, what is the mat2 task mat? Oh, okay. This size, right? So some case. Let's move to this here. Okay, some row become a is not row direction, it's a horizontal direction. That's why it become a column, right? So can compare with mat 2, right? It's a row direction. See this? These are the same, right? What about the sum column? So this one, right? Because we are adding the all element of vertical direction. This one same with 1. Okay. What about the sum all? This value. That is the sum testament or all. The major point of this question is to reuse the your function to solve the question sub question B. Okay. So the sub question B is create a mean function. Okay. No difference between A and B except for these are A is summing up. This one is a mean. So this question is encouraging you to use the mySum function that you already designed, right? So function mean value my mean matrix 2D dimension. Okay, the syntax is the same. So okay, let me copy this here and then delete the inside. Like this. Okay. So here, how can you find out the mean value? We first summing up the all element and divide by the numbers of the elements, right? So we can here can use the mySum, okay, matrix 2D, and then column is a vertical direction that is a sum value, right? And then your mean value become a sum value divided by N R, right? Because this one is a summing up, this is a vertical direction. It's the same. These are the column direction. It's a horizontal direction. Okay, so okay. Last one is the A divided by NC multiply NR. Okay? Does it make sense? So run it. Okay. My mean, right? Run it. No error. Okay. Do you understand this script? Yeah. Okay, good. So let me copy this code. Here, function my sum, function my means, run script. No error, submit. Okay, mean all test is wrong. Okay, so mean all is this should be A, right? Right? So we can fix there's a solution. This should be A. Right? Okay, good. Okay, so we solved around the 6th problem. I would say all the question in the quiz 3 is a very similar format with the one in here. Okay, all the question is designing the function based on the script that we learned in the previous model. Okay, you're completely fine to design your script using the loop and an if statement, but I highly recommend that you use this operator. Okay, so if you develop your logic and loop and then selection statement to solve that problem, you know, your lack of the time. Okay, because again, if you use the more and more loop and then if statement, you have a high risk of the error, so making mistake. Okay, it takes time of the debugging. That's why you're short of the time to solve all this question. So think about, so if you see this one, I mean, you readily see that you're likely make a mistake if you write this kind of the long code. But if you can write this simple one line to solve this problem, I think you have enough time to solve all this quiz 3 problem. Okay, so that's why please thoroughly review the operator. That's very important. Actually, in the function section is kind of if you understand this format, you're done, right? Okay, there's no programming component in Module 7, right? So Module 7 is basically you're studying this function format, not the programming, okay? All the programming parts are placed in before the Module 7 is the loop and then selection and operator. That 3 section is the most important. Okay? Okay, so if you have any question, you can feel free to ask a question through the Learn or the in-person. Okay? Good. See you next lecture. Bye.